So in today's session, we're going to discuss intersection of a line and a quadratic curve. Y equals to mx plus c used to be a straight line, okay? And y is equal to, that is ax squared plus bx plus c is a quadratic curve. This is a quadratic curve. Now we know that quadratic curve is going to be either of this shape, that's we call it a smiley, or this curve, that's a sad face, okay? Depending upon the sign of this constant, if this is positive, it would be a smiley face. If it is a negative, it is going to be concave down or sad face, okay? Right? So from O levels, we know that when we had these two straight lines and we used to solve them using either elimination or substitution method, we used to get a point 3, 5, for example. So 3 and 5 are the points on x and y axis where both the lines meet. Okay. Similarly, here we're going to use the quadratic curve and a line to find out points of intersection simply. Okay. And we mainly use substitution methods here. Okay. So while solving a quadratic and a linear equation, you may come across these three situations. Either your straight line will cut the curve at 2 points, or your straight line is going to be tangent to the curve, or your straight line will not intersect the curve. Ahmed, clear hai all these three cases? Is that clear? While solving a quadratic curve and a straight line, these are three possibilities that can occur. Okay? Right? Ahmed, is that clear, beta?
Yes, sir.
Either your straight line will cut the graph at 2 points, or your straight line will be tangent to the curve, or the curve and line will not meet. These are three possibilities. Ayan, is that clear? How many possibilities are there total
Yes.
while solving a linear line and a quadratic curve? Okay. Now what happens is basically we are simply going to use the substitution method. From linear, we're going to take y value of y or x and you'll substitute it in the quadratic curve. And we get a quadratic equation in x and we solve it, right? These are three possibilities that gonna happen, okay? So number one, 2 points of intersection we would have. Number one point of intersection, or we say line is tangent to the curve. And this would be the scenario. Okay, just for Ayan, this is what we have learned yesterday in this thing. You know, while solving a quadratic equation, this is ax square plus bx plus c, right? Ayan, you remember quadratic formula?
Yes.
B square minus 4ac divided by 2a, right? You remember this was a quadratic formula, okay?
Okay.
You remember this, right? Minus b plus minus b square minus 4ac divided by 2a, if that be a quadratic equation. Okay. While solving a quadratic curve, there were three situations in your O levels. Either you have this situation, or you have this situation, or we have this situation. Either whilst when we solve a quadratic equation, we may get answers 2 and 3, two distinct roots. We may get an answer that is a repeated root, or we used to say no real roots. Okay. Done. These are three possibilities in your O levels while solving quadratic equations. Either we had two solutions, one repeated root, or no solution. You know that this thing, which is known as b square minus 4ac under root, This is known as discriminant because it discriminates between roots. Okay. What it does, it discriminates between roots of a quadratic curve. Okay. It tells us that how many roots a particular quadratic equation may have. So if this b square minus 4ac is positive, any positive value, 2, 3, 10, 5, you will have two real and distinct roots. If this b square minus 4ac was equal to 0, your discriminant is equal to 0, then we will have repeated roots. And if somehow b square minus 4ac becomes negative, we will have no real roots. Ayan, for now, please note it down these three cases quickly. I think we... Ayan, I'll share this document with you. You can go through it.
Okay.
And I'll share the recordings with you as well, okay?
Okay.
Yeah. So here you go. Whenever we have a quadratic equation like this, yes. So whenever we have a quadratic equation like this, ax squared plus bx plus c. Now, when we solve it using the discriminant is basically the thing that is coming under root, in under root, b square minus 4ac, right? So b square minus 4ac is the discriminant thing. So if it is greater than 0, we will have two real and distinct roots. Like when we solve it, you may get answers like this. Okay. And how graphically it represents? Your curve is intersecting at two different points. If your b square minus 4ac is equal to 0, then we have repeated roots. For example, you get 5 and 5. And graphically, it means that your curve is simply touching x-axis. Okay. And if b square minus 4ac is a negative entity, then we will have no real roots. Note it down, please. Is that clear?
Yes.
Amit, is it clear?
Yes, sir.
Okay, that's good. Now, so now we would simply using a linear equation and a quadratic curve, okay? And we'll be discussing all three possibilities. When we substitute linear equation into quadratic and we get a quadratic equation, then for that quadratic equation, if your b square minus 4ac is greater than 0, then that means that this curve is intersecting at two different points, okay? And if your b square minus 4ac becomes equal to 0, that this straight line is simply tangent to the curve. And if b square minus 4ac is less than 0, then this line will not intersect the curve. Okay? These would be three cases. Let's do a couple of questions for better understanding. Okay, here you go. Yes. For example, now question states that find the value of k for which this line is tangent to the curve. Okay, now we know that quadratic curves is like this. Okay, and a straight line is like this. Okay. Okay, so this straight line y is equal to x plus k and y equals to x square plus 5x plus 2 is a quadratic curve. Now we need to find value k for which this line is tangent to the curve. Okay. Now what we do is we use substitution method. So you would say y is equal to x plus k, y equals to x square minus, sorry, plus 5x plus 2. We have two curves, one quadratic, one linear, right? In order to find the solution or tell that these are tangent to each other, what we are going to do is we're going to substitute this y here, okay? So let's substitute it here. That would make it x plus k is equal to x square plus 5x plus 2. And this step is clear. We are simply substituting it, nothing else, okay? Now we rearrange it. X square plus 4x plus 2 minus k. Yes, Ayan and Ahmed beta, is that clear?
Yes.
What we do is we simply solve them simultaneously. We take value of x or y from, linear, and we substitute it in the quadratic. By making it, we get a quadratic equation. Now, if this quadratic equation be tangent to this, then for tangent, we learned about this. This would be the case where b square minus 4ac must be equal to 0. Okay, you'll do a couple of questions and then you'll memorize it automatically. No worries. So if it is tangent, then your discriminant must be equal to 0. You just need to know what is your a value, what is your b value, and what is your c value. Okay. So you would say for line to be tangent, you would say b square minus 4ac must be equal to 0. B square minus 4ac must be equal to 0. So here you go. That is 4 square minus 4ac must be equal to 0. Then that is 16 minus 8 plus 4k must be equal to 0. That is 8 plus 4k equal to 0. That is 4k equals to minus 8. Then k is equal to minus 8 by 4, giving us minus 2. So value of k in this scenario is going to be minus 2. I hope it's clear. Yes? Ayan, is it clear, beta?
Yes.
Okay. So the thing is that what do we have is, see, we basically have a linear line and a quadratic curve, okay? A linear and a quadratic. Done? And we need to find value of k for which this is tangent to the curve. So this is a linear line, this is a quadratic line. We use substitution method, okay? Just like the one we used in O levels, IGCSE, for solving some equations. So y equals to x plus k, and this is x squared plus 5x plus 2. You substitute it, right? And you make a quadratic equation. Now, the scenario is that if this line to be tangent to this, then discriminant must be equal to 0. So we have a, b, and c for a quadratic equation. We do b square minus 4ac is equal to 0. And we solve it, right? Any question related to this? Hello?
No.
Be quick, beta. Tell me. Okay, Ayan. Okay, now in this scenario, for example, if they say that find the value of k for which this line does not intersect the curve, that would mean that it's passing by the curve and not intersecting it, right? We would do everything same, but here we would say if it has to be, not intersecting, then we simply put discriminant less than 0, okay? What we do? We simply put b square minus 4ac less than 0. If they want us to find the value of k for which this line does not touch the curve, and that would be less than, less than, less than, right? Okay.
Okay.
Ahmed, clear है बात?
Yes, sir.
Or Ahmed, if they ask you that this straight line cuts the curve at 2 points, then that means we have to find discriminant b square minus 4ac greater than 0. Okay. So there are total three cases. Tangent does not intersect, intersects at 2 points. For tangent, it has to be equal to 0. That would be the scenario. Okay. Then if they ask you for intersection at 2 points, intersection, then what we do, b square minus 4ac greater than 0. Okay. And if it is does not intersect, then b square minus 4ac has to be less than 0. That would be the scenario. These are three possibilities. First, that is for tangent, then 2 points, then does not intersect. Note it down and you need to memorize these, okay? That's very important.
Okay.
Okay, let's solve a couple of more questions. Ahmed, tell me about question number 1, beta. Ahmed, question number 1. Be quick. Find the values of k for which this line is tangent to this curve. That means that is the scenario, right? This is y is equal to kx plus 1. And this curve is y equals to x square minus 7x plus 2, right?
Yes.
तो टेंजेंट के लिए क्या करेंगे हम फॉर टेंजेंट? What should be the discriminant? B square minus 4ac. Should it be equal to 0, greater than 0, less than 0 for tangent? It has to be equal to 0. Yeah, excellent. So now let's solve them. Y equals to kx plus 1 and y equals to x square minus 7x plus 2. Right? Let's solve them. So we replace this y with kx plus 1 is equal to x square minus 7x plus 2. We rearrange it. X square minus 7x minus kx plus 2 minus 1 is equal to 0. X square minus 7 plus kx plus 1 is equal to 0. Ahmed, यहाँ तक clear है बेटा? Is it clear till here?
Yes, sir.
Okay, so now that means this is your A, B, and C, right? So for tangent, we would say for tangent, b square minus 4ac must be equal to 0. So that is minus 7 plus k minus 4ac is equal to 0. So that is 7 plus k whole square minus 4 equal to 0. Now you can solve it in different ways. You can open it a plus b whole square and then factorize, or you can do it directly as well. Everything is fine. Is equal to 4. You take square root on both sides, making 7 plus k is equal to plus minus 2. So you do 7 plus k is equal to 2 and 7 plus k is equal to minus 2. So k would be equal to 2 minus 7. This is one possible value of k, right? And then second one is k is equal to minus 2 minus 7, making it equals to negative 9. That is the second possibility. I hope it's clear. Yes? Note it down, please. Ayan, clear hai?
Yes.
Ahmed? What? Can we move to next question, please? Yes. Okay. Now listen carefully. Find the values of k for which x-axis is tangent to the curve. Now this is the curve, right? And they're saying that x-axis is tangent to the curve. That would mean that for this actual curve, y equals x square minus k plus 3x, 3k plus 4, right? Now, if you blame that x-axis is tangent, if you say x-axis is tangent, then y must be equal to 0. So you put it 0, x square minus k plus 3 x plus 4 equal to 0. See, one line is this curve and the straight line is y equals to 0. So we use these two lines and we substitute y equal to 0. And we have for tangent, discriminant must be equal to 0. So you say for tangent, discriminant must be equal to 0. So that is b square minus 4ac is equal to 0. That is negative b square minus 4ac equals to 0. That makes it k plus 3 whole square minus 12k minus 16 equals to 0. That makes it k square plus 6k plus 9. So that would be k square minus 6k minus 7 is equal to 0. Now we solve them. We use middle term breaking, I guess. K square minus 7k plus 1k minus 7 is equal to 0. So that is going to be k. K minus 7 plus 1, k minus 7 is equal to 0. So k minus 7 is equal to 0 and k plus 1 equals to 0. That gives you k minus 7 gives us k equals to 7. And k plus 1 equals to 0. That gives us k is equal to negative 1. Okay. I hope it's clear. Yes.
Yes.
So the thing is that when we solve two equations, like one linear and one quadratic, we believe that there will be like either intersection or tangent or without any intersection. Just for a quick revision, what we learned today. So when we solve a linear and a quadratic curve, these are three possibilities that can occur. Okay, and in terms of discriminant, Ahmed, could you explain it? What would happen in first case, second case, and third case with discriminant? Be quick, beta, jaldi se bataएं. For tangent, what it should be? Ayan, aap bataएं. Can you tell?
For tangent, it's equal to 0.
Good.
Two intersections is greater than 0, and one no intersection is less than 0.
Yeah, that's good. Ahmed, is it clear, beta? Yes. Ahmed is in the class. Okay. So uh, this is it. And This is exercise 1L, I guess, and that's the last exercise. Okay. You could solve first 6 questions for today. Okay. 1, 2, 3, 4, 5, 6. These are 6 questions at the homework, right? And for Ayan, I'm going to share this book again in the group so that you can have it, or I'll be sharing it with you directly. You try these questions, and you can also, try the previous questions from the beginning. Okay? Done?
Yes.